Okay, so I think session is on me now. So great. Today we will going to discuss about the Cloud Run. Cloud Run is before that a little bit introduction of myself. I'm Akshay Malviya. Currently, I'm associated with the Capgemini Engineering here in Gothenburg. I'm a software developer by profession. Previously, I was working with the Diaspora Infotech for more than 5 years. Yeah, and I was also lead in GDG Cloud Indore. GDG Cloud Indore is one of the chapter in India regarding the Google Developers Group Cloud chapter. That's why. And if you want to connect with me, feel free to connect with me on LinkedIn. Here is my account link. Uh, Please share your thoughts about the my presentation, and let's catch up more in future. So about the Cloud Run. So before that, I want to make a little bit base about the containers and the serverless architecture. What are those things? How they impact the overall general DevOps work, and why they are so important for now industries to move onwards the more of like a serverless architecture before the and old era where all the management work done by inside the company itself. So what's so hard about the traditional app development and how we can overcome that? So but first, what is important for a company to create an application and functionality for its users? When a company wants to develop an application on their own servers, it must be worry about some aspects more of like selecting the infrastructure, buying hardware, configuring the operating system, deciding if they are going to use the containers or not, defining the storage strategies, configuring networks, of course, configuring monitoring, logging, building pipeline, and on top of that, company needs to be worried about the important aspect of security, patches, updates, server maintenance, rebooting. All of these things are like a very big headache for the general software development startup companies or even the enterprise organization as well. So all these operations are tasks are very important and must be taken care before we write our code. So here comes the serverless into the picture, where how these problems are generally overcome by this. So here's our data center. I hope you can see the garage is not a data center. So what do you think about it? No, sir, seriously, it's not a data center. The serverless still involves some servers, but beside that, the key here is that you, as a developer, do not have to be managed servers. You do not need to install OS updates, patches. You do not need to think about the setup or the entire server's architecture or the monitoring, autoscaling. You have to be focused on your app development. That's what called a real serverless architecture. So we will going to discuss about the serverless first, and I will going to talk in two formats. First is the operational model, and another one is we will discuss soon. So in the operational model, as I said, there are no servers to manage, which means all the infrastructure security concern are deal with. The other aspect of operation is that the only paper use what they use. This means the ability to scale to zero and billing closely aligned the cost incurred by the running codes. So this is the operational model where the serverless comes into the picture. And for a developer, for the people like us, the important thing is it's a programming paradigm. How we will write our code in such a manner that it will going not going to affect the directly server to client architecture, whether it's more of like a event driven or a service based model. So one would say a cloud native development is one of the solution for such kind of problems. So instead of shipping the code and libraries as part of your application, you instead consume service that are important to you. This service can be your own services or someone else, but Instead of tightly coupled intertwined set of modules, your application and underlying services are event driven. Whenever it required, you trigger them and use them. So such kind of architecture comes into the serverless picture. They are triggered upon the users and such as versatile software architecture. And finally, all this makes sense when you don't tie yourself with a specific platform implementation details. Your code and your workload need to be portable across multiple implementations, because Cloudant is more of like platform independent. You do not need to be depend on particular language or particular platform. It's a multiple platform implementation, multiple product implementation, and obviously multiple cloud vendors as well. Yesterday my application was on Azure. Today I want to move further on GCP. So here the Knative comes into the picture, which help us to migrate our application from one cloud vendor to another cloud vendor. So let's discuss more about the some serverless aspect of GCP, which they provide us for implementation of Cloudrun. So some serverless set of functions are here. You can see that that is a much broader than a function as a service. Instead, it span across the compute, database, data warehousing, even analytics, processing of data, ETL. I can see machine learning trading modules as well, binary storage systems, as well as the message queues. So compute the compute part, it on is not enough. We need to think about all the pieces. We need to move from an architecture from the bottom of the stack toward the top of the stack. So we will focus on the compute part of those GCP services, which are important and can be used into the cloud run to make the application better. So let's discuss about more into compute first. So there are some compute applications which are available over the GCP. It comes no surprise that within the GCP there are several products on each of these hexagons, serverless products of all these hexagons available, more of like a cloud storage, ML engine, data flow, cloud data store, etc. A very tangible example for non-function as a based service, serverless service is data warehousing. Setting up a data warehouse from scratch for a data analysis is a complex project that requires provisioning of hardware and specialized systems by experienced technicians. On the other hand, with the BigQuery, our serverless data warehouse product, you can simply open a console and it is ready. So how it is easy to use the two aspects. One is a data warehousing, which is a non-serverless function-based architecture, and on the other hand, we have a BigQuery, which is serverless architecture. And on just a one single console, boom, you have your entire data structure available to use. So you can insert in BigQuery, like you can insert a table, insert a data. It has a tons of millions of data which can be easily available over just simple clicks. So other examples of serverless are fully managed database such as cloud data stores, TensorFlow training and prediction of cloud ML engine, and many more. So let's discuss about the cloud function and app engine, because those two things are relatively similar to the cloud run, and how they are differ from them, and how we can overcome the problems on these two services, and top of that, why cloud run is better to them. So focusing on the compute aspect, serverless are there are only currently two services, which are cloud functions and app engine. And let's discuss why these two are only available. So generally in event driven serverless application, this is very common pattern that a user or a service emits an event first, then need to be processed with the innovation to other service, API or a data store or a message queue or a pops up message. This is all called event driven serverless application data architecture. So here comes the cloud function into the picture, where it's a proper function as a service available on GCP. And it's a technology, ideally technology for such a thin microservice implementation, whose job is to act as a proxy to further calls to other, you can say, services. Without some have limited business logic. So for the application which are has limited business logic and needs to be available over the serverless architecture, in that case we can use a cloud function which are available over just a single API call. As I can say, it's a function as a service available service calls. That's why. But here we are discussing more about enterprise applications as well. They are not very less. They are bulky application, and for that we need the entire containerized stateless system, which then we need to use Cloudant. So I hope that till here we had a basic understanding of how the serverless infrastructure work. So now let's discuss about the Cloudrun, how it is a cherry on the cake. So Cloudrun, firstly, on typical definition point of view, I would say Cloudrun is a managed compute platform that enables you to run the stateless containers. Please mark my words, it's a compute platform, stateless containers that are invocable via a web request. Web request can be in any form, like either a HTTP web request, either a PubSub event, either a gRPC, either a WebSocket. It can be anything. So Cloudrun is serverless. It abstracts away all the infrastructure management, which we do not need to be worried. So you can focus on what matters most, building great application. It is built from the Knative. It's a great for those people who had a great understanding into the Kubernetes and want to migrate into the their application, containerized application, into the Cloud Run. So it helps us in the form of Knative as well. Before that, I want to show one small video about Cloud Run, how it is important, and why, which kind of services Cloud Run provides.
Cloud applications like web apps, mobile APIs, and background jobs. But choosing a cloud solution often comes with trade-offs. On the one hand, you can choose to manage your servers, but this can mean provisioning and configuring them yourself, plus worrying about scaling as traffic patterns change. And you might run the risk of over-provisioning resources and paying for more than what you need. On the other hand, you can pick a traditional serverless solution, but this can limit the languages and libraries you can use, and may require code changes and make it harder to move your application. What if you didn't have to make that choice and could enjoy the best of both worlds? Introducing Cloud Run, bringing serverless agility to your containerized apps. You can use Cloud Run to deploy any stateless HTTP container. This lets you write your code in your favorite language with the framework or binary library that works for you. Then simply specify the language, your dependencies, and your start script in a Docker file. And with one command, package it up into a container. And boom, you're good to go. Your app is now deployed and running in the cloud. You can forget about provisioning or managing servers. Cloud Run does that for you. Cloud Run automatically and quickly scales up or down based on your incoming traffic, and even scales down to 0. And you pay only for the resources that your app uses, billed down to the nearest 100th millisecond. And because Cloud Run is built with Knative, you can use it with your own Kubernetes engine cluster too. With Cloud Run on GKE, you can build and deploy apps to your own Kubernetes cluster with the same easy experience and benefits. So the next time you want to build a great app quickly, check out Cloud Run. Get started today.
So as you can see, I hope by this video, you all had a very generalized understanding of how cloud runs differ from the cloud functions and how it is generally used. So as I can say, it's a serverless, stateless container. The containers which we generally known as the Docker containers. So yeah, it's a Docker container which is available in a serverless, stateless form, and it can be a portable, flexible, scale up, and pay when you want. Only for those things which are utilized into the Cloud Run. So let's discuss about how does this work. Today, due to the time constraint, I will not going to discuss over the Google Cloud Console, but yeah, I'll share about how these things are going to be work in a real world application. So, for example, we have a 4 different use cases to invoke the Cloudant application, which is available over the Cloudant. So one of the best and the most common method is HTTP web request. Here we can send trigger cloud run hosted services with the simple web request call. But keep in mind that all these web requests need to be stable HTTP URL. So it means that we should have a stable domain name. Some use cases include into the HTTP are more of like the RESTful web APIs we generally used in software developments, the private microservice architecture which we generally had, HTTP middlewares as well. Many of the applications has or the reverse proxy of your web application, prepackaged web application, etc. For example, another use case is with the gRPC. It's a Google Remote Procedure Call. You can use gRPC to connect the Cloud Run service application with other services as well. For example, to provide a simple high performance communication channel between two internal points. gRPC is generally used for streaming, or even you can use it for the internal microservice communication as well. When your project is into the microservice architecture and one microservice and another microservice want to communicate with each other, so in that case we can use it as well. WebSocket is a great example to use Cloud Run because of the streaming channel between the two endpoints, and which are only available when to use. And trigger from pops up is another use case in which we can push a message to an endpoint of container, and it runs over the service over the message subsequently delivered to container on a HTTP web request call. So these are some general use cases where generally cloud run services are used to work. I want to show next what will be the workflow of any application which is hosted over the cloud run. So in general software development, we have multiple phases of developing one application. One is more of like cloud code. Here we generally develop our application, or you can say cloud code is one of the tool which is available over the GCP to develop a code. But we are saying that our application is already built, so the code is the process or phase where the application is already completed, and now we have to make a build. So cloud build is one of the service which is available on GCP to build your code, to make it deployable executable application. Now it comes to a deploy section, and here comes the role of multiple serverless services available over the GCP, and one of that is Cloud Run. Cloud Function, we already discussed how it is going to differ from the Cloud Run, because for those applications which have very less amount of compute is can be hosted into the cloud as a cloud function. But all those applications which are enterprise in nature, which are bulky in nature, need to be inside the container and having multiple executable environments. Those need to be worked inside the containers. So those applications should or can be deploy at the Cloud Run. And for the monitoring, we can use a Strike driver, which is a monitoring tool available over the GCP. So regarding the summary, we have multiple paradigms we generally discuss about the cloud functions and serverless architecture and the cloud run. So again, the cloud functions are tends to be a single purpose, no complex business logic. App Engine typically expose HTTP services. That's why we cannot use it in such cases. They share the same autoscaling and sandbox technologies which are available. The unit of computing is yours to choose. So that's why you should no longer be making an architectural choice based on the operational consideration. Instead, slice and dice your application. Anyway, you think it makes sense to be more agile, to build a better apps that deliver value. Uh, I hope you understand my session. And that's all from my side.